New num is 100, right? We get that. So we get that. New num is 100. And let's see, we should just new num is equal to 100, right? So it multiplied I times 10. We got that. And to show you how that would work, well, first of all, let's see how that would work with the difference with the plus plus is this. First, it's the equivalent of moving this thing up here, doing it before. So now it's 110. That's the difference. And I'll show you how that would work in reality. So now let's say plus plus, right? You get 100 again, right? But if I move the like this, now we get 110. So the difference is if you do the plus plus before, it adds 1 to I, then it does the multiplication. If you do it afterwards, it first does the multiplication, then adds the 1. And if you don't get that, don't worry about it. These are shortcuts. You don't have to take the shortcut. In fact, I advise you not to. What I advise you to do is do it longhand. And this is longhand. It's one extra line to do it longhand, but it's less confusing. So don't worry about it. If you really feel like you want to try the shortcuts, that's okay. But don't feel compelled to. Increment, decrement operators, are useful. I use them all the time, but I've been programming for 25, 30 years. You can just do it shorthand, though. And again, I would recommend not bothering too much with all the shorthand stuff when you're first learning, because it gets really confusing. The truth of the matter is that most programming languages have so many shortcuts that if you wanted to, you could write the entire program on one line. That is not a good idea, even for someone who's really advanced to do that. But and when you're starting out, certainly not. So I wouldn't worry about the shortcuts right now. They'll come later if you feel comfortable with it. Numeric type conversion. This is what we call promotion. So byte I equals 100. A byte can go up to 255, so no problem storing 100 in there. Long k equals I times 3 plus 4. Not a problem. It's 300 plus 4. Now, that would not store back in I, because I has a maximum size of 255. But it will store in a long. Not a problem. And then double D is basically, now we go even a little bit further, making it 3.1 plus k divided by 2. This is definitely going to wind up being longhand. Rather, a floating point number. These are all promotions. Byte to long is a promotion, and long to double is a promotion. A demotion would be going the other way around. Okay, when performing a binary operation involving two operands of different types, Java automatically converts the operand based on the following rules. If one of the operands is double, the other is converted into double. Otherwise, if one of the operands is float, the other is converted into float. Otherwise, if one of the operands is long, the other is converted to long. Otherwise, both operands are converted into int. So essentially what it's doing is it's playing it safe. And it's going to go to the safest data type, which would be double, and then work its way down. That is the safest to assure you don't lose data. It's also the most inefficient on your memory, but it's, what's more important? If you've got 4 gigabyte of RAM, are you worried about using a couple extra bytes, or are you worried about producing a financial report that's off by thousands, tens of thousands, hundreds of thousands of dollars? You're not going to get fired for using a couple of extra bytes on your computer. You may get fired if you misrepresent the financial report. So safe is usually best. You can implicitly convert something if you want, which means you're telling Java to convert it the way I want it to convert it. Now, you have to be careful, and actually, if you want to demote a value, I believe Java forces you to use explicit typecasting, which means in parentheses around the number, you're telling it what the data type should be. So 3.0 would typically be a double or floating point. If you try to store that in an int, normally you would get an error, I'm pretty sure, if you tried to do that. Let's see. All right, so let's just pull that out. If I do that, that's okay. However, if I remove the typecasting, I get an error. Possible loss of precision. Required int found double. And so what it's saying is it's an error to demote something, unless you tell me that's what you want to do. So Java will not let you accidentally demote data. But if you tell Java with this, what we call this explicit casting, that it's okay, that's what I want to do, then you can do it. But Java makes you make it clear that that's what you want to do. And that avoids accidents. So that's actually a good thing. This is a problem because this will result in a floating point number. So again, we would probably get an error with this if we tried to do it. You get an error. Possible loss of the same thing. However, if I typecast this whole thing to an int, it doesn't like that either. Maybe we need to put everything on it. So I think what Java is doing is it's forcing me to typecast everything, which is interesting. There it is. So Java is really forcing you. Will they always round down? Yes, it will always round down. Well, it's not so much that it will round down. What it's going to do is it's going to lop off everything to the right of the decimal place. So in effect, yes, it will always round down. Of course, this is another problem. If you're calculating financial amounts, you have to use the double, but double has a precision out to 8 decimal places, and you don't want to display that as a monetary value. So how do you fix that? They're showing. Let's see what they're doing. You start with an int. You add 4.5 to it. It would be a 4 after the statement. That doesn't solve your 2 decimal point issue. What if you wanted to round up? Before you do the casting, you add a 0.5 to it. So, for example, in this situation, let's just say that I'm not doing this with 2.0, I'm doing it with radius, right? Which is double. Where's radius? It's double. I don't like that at all. Variable radius may not have been initialized. So let's just say is equal to 0.0. Okay, so what if I want this to be rounded up, is what you're saying, right? It's a little trick that will do it. So, oh, hold on, we probably need to do it this way first. Hold on. There it is, yeah. So what you do is you add a 0.5 to it, right? Because it's going to get it down, rounds down automatically. So if what's in radius is, let's say what's in radius is equal to 2.49. If we add 0.5 to it, it's 2.99, right? And then it rounds down, it's 2, which is what should happen. But if this is 2.51 and we add 0.5 to it, it's now 3.01. And it lops off everything after the decimal place, but it's now 3. So, in effect, we've rounded up. Oh, you want to round up. What if you want to round up? You just add 1 to it. So, instead of adding 0.5, can get a little tough, because if you add 1 to it and it's exactly 3.0, you've got a problem. The only way to really do it is to try and, a little bit of wiggle room, like 0.99999, and that would cause it to round up. You can't say 1, because it could be at 3.0, and if you add 1, it's now 4.0. But if it's at 3.0 and you add 3.999, so that gets a little tricky, but you can play with the math a little bit to get it to do something like that. Does that answer your question? Okay. Yes, it does. Okay. Let me see what they're talking about here. So displaying in decimal places. There's actually an easier way to display something in decimal places, with 2 decimals after it. I don't know why they're not showing it to you. We'll get to it a little bit later.